Hello everyone. About a year and a half ago, together with 4 friends, I started a new company called Git. I'm sure you all remember the excitement of starting a new project from scratch. Well, I wanted to ensure we would do things right from the start. So when we decided we wanted to build our app using microservices, and when we started to build the first service, I said to myself, well, let's make sure we add CI/CD pipeline for the service today. And we did. But then guess what happened when we added the second service? Well, of course, we did not do it. And it got me thinking, why do we need to think about adding CI/CD every time for every repo we create? And then it hit me, centralized CI. And this is what I want to talk about with you today. I'm David Melamed, co-founder and CTO at Git, born in France but living in Israel with my wife and my 4 kids for the last decade. A few days ago, I tested positive for COVID when I got back from a talk that I gave in Oslo, and therefore I'm currently still in isolation at home with the inability to be there with you in person, which I regret very much. I'm passionate about technology, cloud, and security, and Git is a little mix of all of that. We provide an automated security plan as code in order to continuously monitor the security of your app. In order to do so, we integrate, we configure, we orchestrate all sorts of security tools and processes, some being open source and in the future also commercial ones. But let's go back to the beginning. Before even writing the first line of code, I had to pick an architecture. MonoRepo or multi-repo. Putting all my code in one place or using microservices and following the single responsibility principle. I'm sure that as a developer, you all ask yourself the same question over and over when you are about to start your new project, right? Should I manage all my code base in a single repository, allowing me to refactor easily if needed and having a common culture among my teams? Or should I rather favor the ability to have independent deployments and versioning and more autonomous work in each team who can decide in which language they want to code or which web frameworks they are more comfortable with? The monorepo versus multi-repo really seems like a never-ending debate with its pros and its cons. And what about CI? On one hand, I have a single CI file for my whole application, and on the other, I have one file per repository that I need to remember to add every time I create a new one. And then I need to manage it with obviously a lot of duplicated code. This seems like a headache. And I wanted to decide whether I want to go with monorepo or multi-repo without having to consider this headache. So what if there was another way? Of course, you could create a template for new repos which would include a predefined CI pipeline, but I don't think it would be a really sustainable solution since I would still need to update all my existing repos every time I decide to change my pipeline. And so I thought, what if I could have a central place where I can keep my CI pipeline configuration and find a way to trigger it from every repository? What would it look like? Well, basically, what I would need is the ability to listen to every PR using some backend service, which would trigger the CI pipeline automatically with the relevant context in order to clone the branch and run my tests on it. Simple enough, right? Well, let's take a look at a more concrete example then. Here, let's pick GitHub as our SEM, the way we want to store our code, and GitHub Action as a CI system. But of course, it can work with other setups like using GitLab or using Bitbucket and Jenkins, for example. But for the sake of this demo and this talk, let's pick up GitHub and GitHub Actions. So let's say I have a GitHub organization with a repository called A. When I open the PR, GitHub automatically sends me some event, let's call it PR opened, and it sends to my webhook listener. This listener leverages a feature in GitHub called dispatch workflow, which can trigger a GitHub action remotely. And well, this workflow was stored in my central CI repository in my GitHub organization. And that should run all the tests that I need on my PR. So this seems like a quite simple setup, right? Let's see what I need to implement this in real life. So what do I need? Basically, first I need to create a GitHub application, of course. And this will give me access to the GitHub API. And then I will be able to register and receive all the events about open PRs. And I will be able also to trigger remotely my CI workflow. For the webhook listener, I will implement it in Python. And I decided to have a server with async calls to GitHub, so I picked IO-HTTP as a web server and GitHub as a GitHub API wrapper. And finally, for local development, I need the ability to have some public URL, since GitHub needs to send me the open PR events. And for that, I will use ngrok, which can create some tunnel and provide me with some unique public URL. So let's create the GitHub application. What do I need to do that? Well, first, the webhook URL, which will point to my ngrok public URL, followed by /webhook. The path that will route to the function will handle the events. I also need to define some webhook secret in order to verify that the call to this endpoint is genuine. Next, I need to define which permission this application will need. So, what do I need there? Action is the scope, is required to dispatch the workflow. The scope of contents will be required to clone the code in my CI pipeline. Pull request will be required in order to receive the events together with subscribing to the pull request events. Checks will be required later when we'll have to deal about checks in the PR. And finally, I need to define a couple of environment variables for my webhook listener to work, just like the GitHub app ID or the webhook secret and the certificate, the private key that is used by GitHub to verify my token. Okay, now let's see how do I build this centralized CI and how we can put in practice everything we saw so far. So let's start with the IDE. Okay, here in the IDE, I have my project, and I have a simple file, a main.py, where, as you can see, I have my web application, and I have one unique endpoint, /webhook. If I'm checking what's happening inside /webhook, as you can see, I'm listening for events, and here I'm dispatching it internally. And if you're looking at which event I'm currently listening on, I'm listening to pull request open and pull request reopened. And they're both going to the same handle PR function. What does this handle PR do? Well, it's quite simple. Basically, I'm using the installation ID that I receive as part of the event. And from that, I'm generating some installation access token that will help me talk with the GitHub API. And then I'm building some payload that will include the metadata or the config, the context on which I want to trigger my centralized workflow. So for that, I need basically the original repo, which is based on the owner and the repo, and the head SHA that is part of the PR that I'm currently listening on, and the event is currently received from. And of course, I also need to send token that will help me in the centralized CI workflow to clone the original repo. Okay, this is the place where I want to trigger my centralized workflow. So it's in the centralized CI organization. This is a test organization that I created for the matter of this repo. And as you can see, I just need to post some requests to this to GitHub in order to trigger the centralized CI. So what happens inside the CI itself? Let's see the GitHub action workflow. Basically, if you don't know GitHub action, it's a very simple YAML file to define a workflow. You need first of all to define what is the event that that will trigger your workflow. So here, as you can see, it's basically defined. It's triggered every time there is a workflow dispatch event that is sent to GitHub. And this is the input, so this is the payload that I'm sending to this workflow. These are the jobs. Right now there's only one job, and this job is doing the following. First of all, I'm setting up Python, and then I'm checking out the original repo based on the payload. So this is the exact path of the repository that I want to clone, and this is the SHA that I want to clone so that I'll be able to clone the repo with the current branch that the PR is based on. And I'm also sending the token in order to be able to clone the repo. And finally, I'm cloning the repo in /code, and then I'm running Flick8 that I'm installing with pip install, and I'm running it against this /code /code directory. Now that I have this, here you can see in the project I also have these requirements.txt, so something very, very simple. And now if you're going to the terminal, here you can see that I started ngrok, and so I have a public URL, or this one with HTTPS, that is redirecting to localhost 8000. And then let me start the server. Okay, now the server also started. And now let's go to the browser. So in the browser, this is the repo that I just showed. So if you want to be able to clone or fork this repo, you definitely can. You can play with that. And this is the test organization that we'll use for the demo. As you can see in this organization, there are only two repositories. The first one is the centralized CI one with this workflow that we just showed. This is the CI 0, and this is a test repository that we'll use right now to demonstrate how it works. So I will just actually we'll just change an existing file just to show that it works. So I'm creating a new branch, and I'm creating a pull request. And then what I will do is go to the CI and go to actions. And what you can see is that there is a new action that is currently triggered. And if I check in the details, I can see that the repo that was checked out is my test repo, and here it ran Flick8. Okay, and actually it worked. There was nothing there, so it's green, right? Now just to show you that it really works, if now I'm changing something else, let's say in the main file, and I will just add some line here. Okay, creating a new PR. going to action in CI. You'll see here there's this new workflow that is triggered, and actually lint is failing because I added extra lines, right? So it works. But as you can see, there is an issue here, because if I'm coming back to the original repo, and if I'm checking the PR, let's say the last one, I have actually no indication in the PR itself that something happened. No status update, nothing. Okay, so what should I do now? Basically, what I would like to do, or what I would like to see, is something like that. Some check that will tell me that something happened. There was some PR, there was some test that was performed, and whether or not the test was successful, right? This is what I would like to see. So how can I make it work? Well, basically what I'm missing is the feedback loop, right? Something from the CI that will trigger back some kind of reporting inside the PR itself. Okay, let's see how we can make it work. Okay, basically the flow should look like that, right? The job is checking out the code, telling the backend to create the check, running the linter, telling the backend to update the check. And for that, we can leverage the feature of GitHub around checks. So the updated diagram looks like that. Basically, what we want to do is to start checking out the code, and then we want to create a check to immediately inform that there's some check that is running. Then we, once we create a check, we want to be able to run the linter. And then once the linter finishes, we want to be able to update the check. So the linter should be able to return some status code so that I can know in my backend how to update the check, whether or not the check should be pass or fail, right? So this is basically what we want to see now. Let's see that in action. Let's go back to the IDE, and this time I will open another main.py with a more advanced version. So in this version, I also want to take care of the checks. So in addition to what we had before, which was the /webhook route, I have now new routes. The first route I have is a route to create a check with the post method. And the second is a put method where I can update the check with the specific check run ID. So let's see how the check is actually created. Basically, it's very simple. I'm getting from the payload all the information about the target repo, the name of the check, and the token that I need to use in order to create the check on this target repo. What is important here is that I also need this check run ID, and this is what I'm returning from to this API. The second endpoint, I'm updating the check. And here, the code is quite similar, but as you can see here, first of all, I want to read all the properties of the check, and then I want to update the check with the status of completed and a conclusion that comes from the payload itself. Okay, so that was the changes here. Everything else is the same. And now I want to show you exactly what is changing in the CI itself. So in the CI, the first step after I set up Python is actually to create the check. And for that, what I want is to do some kind of curl command to my backend /check. Okay, so here in this case it will be my public URL. And the data I will send is basically the installation ID that I get from my workflow. I have the owner, the repo, the headshot, everything else is part of the same context, and the name of my check. And what is important here is that I want to save the check run ID as part of the GitHub environment variables so that I can use it later on. Then I'm doing the same thing that I did before. So I'm checking out my code. I'm running the linter. And as you can see here, there are two different steps. If failure, so if the previous step failed, then I want to save into environment variable that the result is failure. And if success, I want to save that it was success. And then always, in any case, what I want to do is to curl and to send a request to my backend with this specific run ID that I need to update with the conclusion, which is based on the value of the result environment variable, right? So this is the code. Now let's see that in practice. The only difference here that I will do in my terminal is that instead of starting here, I will start with the updated version. Okay. And now let's go to the browser. So I will actually do the same thing that I did before. I will add a few lines here. That should make my PR fail, right? The test on my PR, the linter on my PR. Let's create a new branch for that. And let's create a pull request. Now, let's see what happened. First of all, in my terminal, I can see that I got the first request on the / webhook. So GitHub returned to me that is webhook, and then I get this post to check. Now, what happens in the browser at the same time? The check got created. It's now in progress, and as you can see now, it's failing. Now, right now, if I want to check why it's failing, if I'm getting to details, I don't have the results here. So this is something that I will still need to fix. For example, here, I need to fix that view more details and centralizer need to go to the log. The log is right now in another repo, and that's why it's not working automatically. So if I'm going here into the action, here, I can see the last job, and here I can see actually the log. But right now it's not connected, something I will need to fix. All right, so what you saw until now was how to create the centralized linter with some feedback loop that updates the PR status of the original repo. And the main advantage of this is that, as you can see, developers don't need to think about adding it every time. It works behind the scenes transparently, which is pretty cool, right? But as you can imagine, we're not done yet. And there are still a couple of things that I did not have time to touch. But first, where you can find the code you just saw, well, the URL is just there. Feel free to fork and submit your improvements. Second point is that the way developers well, the most dev-friendly way to show the results is actually to show them as comments in the PR, as you can see here in the screenshot. So I have a few more minutes for questions if you have some. But before that, thank you a lot for attending this talk and hope you enjoyed as much as I did. Talk to you live in a minute.
Please submit your questions via Slido, and ideally not in the room to keep also the remote attendees happy. Thanks for the great talk, David. The first question, I think it received quite a few upvotes. What is the benefit over the reusable workflows, which is a GitHub built-in feature?
So basically, the advantage is that you have one central place where you can define everything, and all your settings are centralized in one place. Using the reusable workflow, you can define the workflow once, and you still need to define it in every repo, and you still need to copy the same file over and over. The other advantage is that if you wanted, you can make things that are more advanced, just like, for example, if you have some differences between the workflows, you just need to override some specific settings by adding some file in one of the repo. And in your central repo, you can just read the specific file and have a different behavior, which is something that you cannot do easily with reusable workflows.
Okay. Now, sorry.
I cannot hear you anymore.
Yes, okay. Now for the next question. What are you thinking about Dagger, which is the new project of the Docker creator, which solves exactly this problem and more, like testing and usage in different CI/CD tools?
I think it's a great project. I just been started to test it. Actually, I thought about it about decentralized CI about a year ago. So Dagger didn't exist yet at the time. I think I'll definitely give it a try.
Yes, thank you. Then,
okay,
once again. So, thank you. If your GitHub workflow is unique to the updated dev repo, do you still put the workflow in the centralized CI repository, or do you enforce centralization of all workflows?
So the major advantage of enforcing centralization is that you can enforce some security checks, for example, that you want every repo to be part of. So you don't want the developers to decide whether or not they want to, for example, enforce even linter. And so even if you have some unique features in your pipeline, I would still use centralized workflow, but I would rather use the fact that you can override some of the settings or some of the jobs inside your specific repo.
Yes, thank you. I think we have time for one last question, and this would be, can you disable merging without running checks? It seems like when you created a PR in the demo, you could just merge it quickly without checks.
So basically, that's because in the demo, I actually used a backend that is local. And so first of all, it took some time to create a check. But if you add a branch protection to all your repos, and you actually enforce the fact that you need a specific check, for example, let's say you have a global check, then you can prevent merging before all the pipeline is running.
Yes, thank you. We are out of time now. Once again, thanks for your talk. Thanks for
Thank you very much.
Still joining in Zoom, even though like the situation didn't allow it. And yeah, we will continue in 10 minutes with the next talk here. And thank you everybody for coming.